Hello everybody, in this lecture we will be solving 1991 IMO problem number 1. Here is a view of this problem. We're given triangle ABC and we let I be the incenter of that triangle, and the internal bisectors of the angles AB and C meet the opposite sides at A prime, B prime and C prime, as you can see in the picture. We need to prove the following inequalities. So we can start by employing the angle bisector theorem to establish some length relationships. For instance, if I apply angle bisector theorem in triangle AB A prime B, A prime B to AB is equal to A prime I to AI. In a similar way, applying angle bisector theorem in triangle AC A prime, I get A prime C to AC is equal to A prime I to AI. Notice now that if we denote the side lengths as A, B, and C, we can then establish the following. So for instance, A side BC is equal to BA prime plus A prime C, but BA prime, we can get a relationship from this one. AB is simply C, so C times A prime I over AI plus, for A prime C, from this second relationship, we can get that AC is just B, so B times A prime I over AI, or just simplifying, we get B plus C times A prime I over AI. And as a result, therefore, we can get AA prime to AI. This ratio, well, so would be equal to, I can split AA prime into AI plus IA prime over AI, and that's just 1 plus IA prime over AI. But from the previous result, so if I move B plus C to the other side, that's simply equal to 1 plus A over B plus C. You can, in a similar way, find analogous expressions for BB prime over BI and CC prime over CI as well. Namely, for BB prime over BI, one would get 1 plus B over C plus A, and for CC prime over CI, we would get 1 plus C over A plus B. And now we can substitute them into the problem. So therefore the problem reduces to the following. Well, obviously I can find the common denominator, and so therefore the problem statement reduces to, in terms of lengths, side lengths, 1 over 4 strictly less than, and I just revert them, so B plus C over A plus B plus C, C plus A over A plus B plus C, and finally A plus B over A plus B plus C less than or equal to 8 over 27. So that's exactly what we would like to prove. There are numerous approaches that one can employ to finalize the proof. In fact, the right-hand side is significantly easier to handle. So let's start with the right-hand side. By simply applying AMGM, we observe that this product, B plus C times C plus A times A plus B, is less than or equal to B plus C plus C plus A plus A plus B all over 3 cubed, and that's simply equal to, we will have 2 of each one of them, so 2 over 3 cubed, which is just 8 over 27 times A plus B plus C cubed, and that's exactly the inequality that needs to be proven for the right hand side inequality. Alternatively, one could have used Jensen inequality as well. All you do is you can simply take the logarithms, and based on the logarithms one can apply Jensen inequality to the logarithm function is concave, so use log function which is concave, so you can, I just leave it to you guys if you want to. So for the left hand inequality I will be using Ravi transformation, right? Just to remind you, you can write the side lengths in terms of a equals y plus z, b equals z plus x, and c equals x plus y, and substituting these values into our expression in the middle, we get that b plus c times c plus a times a plus b all over a plus b plus c cubed is simply equal to, so we would have a very long expression obviously, so would have x plus y plus z plus x times x plus y plus z plus y times x plus y plus z plus z, all divided by 8 times. And the reason I say 8, because once you substitute a with y plus z and b with z plus x and c with x plus y, we will have 2 of each of the variables, and then the 2 can come out as 2 cubed. So, and then what's remaining inside would be this expression here, cubed. And now I can just follow the algebra, which shouldn't be too hard. In fact, yeah, let's just factor out the 1 over 8 first. And notice here that I can just split it intelligently. And so what I would get is, I would get a 1 plus x over x plus y plus z times 1 plus y over x plus y plus z, and finally 1 plus z over x plus y plus z. And then further, when we multiply things out, I still have the 1 over 8. 1 times 1 times 1 is just 1 plus, and then we would have 1 times x plus this, and then 1 times this, and then 1 times this. So therefore we would just get x plus y plus z over x plus y plus z, and then a bunch of other positive terms, but all positive, right? So now it's clear that this is also 1, so 2, so you would get 1 over 4 plus 1 over 8 times some positive terms, which is obviously strictly greater than 1 over 4. And that solves the problem. Hope you enjoyed it, and looking forward to see you guys in our next video.